Well, what we do is basically we try and look at some of our models, means like numerical simulations, which are basically nothing more than a mathematical experiment to see how things, what you would predict to see in the orbits of MMS. So we try and see what we expect, try and find out what we would expect to see, and then compare actually with present data from other spacecraft to see if that makes sense, and then project it to what MMS will see. I'm particularly interested in the acceleration of electrons in the magnetotape. And I see these electrons, we've seen them on the Themis spacecraft, on cluster, accelerated all the way up to hundreds of keV, which are near the radiation belts, about 10 Earth radii or so. And what would be really interesting for me is if we could really understand how this acceleration occurs. At present, we think it's due to dipolarization fronts, which are strong components of the north-south components in the magnetic field, and we think they're related to them, and somehow they get accelerated. I think it's a long story, but I started my career, as you can tell from my accent, not in this country, but I started in Egypt. And so at that time, a long time ago, it was not accepted for women to go at all into science. But I really wanted to do science because I loved maths. And so that was the beginning of the journey. Then I went on to Imperial College in London, and I got my PhD there. And my thesis advisor actually is the one who started reconnection, Jim Dungy. And so I was very lucky. And so I got all this information about reconnection and hopefully some knowledge from him, though not enough probably. And I tried to, when I went to UCLA, I decided, well, let's try and do something more than theory or observations. So I started a simulation group. And that's where we started numerical simulations to try and see how far we could push the theory, the analytical theory, extend it, and how much more we could get to compare with observations. I always tell them, you know, that because I have many, because I teach a lot at UCLA. So when they come to me, I always tell them that you have to realize that if you're going to do this job, it's going to be a lot of work. And you must really like it, because you don't want to spend all these hours at work if you don't enjoy it. That's number one. Number two, assuming that you like it, then you have to have a good background in maths. So I tell them you should take extra classes in maths and really strengthen your ability in maths and science, especially as you're an undergraduate, because it's a unique opportunity in graduate school, especially in the States, which has all these classes that you offer, so that they become prepared. And then it's also great if they could be interns or something in one of these national labs, because they get hands-on experience. And that's a very unique opportunity. In fact, when I'm here at Goddard, in the meeting, I see all these young postdocs, and I think it's a great opportunity for that.